Hello, my name is Randy Hootman, and on behalf of Yggdrasil Computing, I'd like to welcome you to this seminar on the installation of Linux. I've been giving these seminars for a while, and we at Yggdrasil thought it would be a good idea to make these seminars available on video. This is the first of these productions. There are future videos planned. Professionally, I've been programming computers since 1968. I've worked here in Silicon Valley as a software developer for the past 6 years. This has included working on such projects as DBase 4 and the EOPen computer. But I'm really quite excited about the abilities of Linux, as I've always wanted my own personal Unix-like workstation at home for my own use. After all, that's what I was using at work, and I felt very limited by the operating systems available currently for the PC. Well, what is Linux? Linux is a term that loosely refers to all the software that goes together to make a usable Unix-like operating system. Technically, Linux is the POSIX-based kernel written by Linus Torvalds from Finland. POSIX is basically a public specification for a Unix-like operating system. Linux started out as a personal project by a student named Linus Torvalds. He wanted to develop a kernel to replace an earlier, less powerful Unix-like operating system called Minix. Linus released the source code for the Linux kernel to the internet, and it has since blossomed into what it is today, a stable operating system. While complete source code for the Linux kernel is available, it is not in the public domain. Linux is copyrighted by Linus Torvalds and the many other contributors under the Free Software Foundation's general public license. The Linux kernel is free software, but if you distribute copies of the Linux kernel, you must either include a copy of the source code or take certain steps spelled out in the general public license to ensure that the source code is readily available at essentially no cost. Linux was written entirely from scratch and currently runs on Intel-based platforms that support a 386 or better processor. There are currently ports to other platforms under the way. This includes the Motorola 68000, the DEC Alpha, and the PowerPC. Linux is developed using an open development and distribution model. This is in contrast to the traditional closed centralized model of commercial software. What I mean by this is that the current version of Linux is always public and anyone can use it. This results in new functionality being released, bugs being found, and corrections implemented very quickly. From personal experience, I know that this can sometimes only take a matter of hours from submission of an improvement to a new public release. This would be an impossible feat for the commercial software industry to match. Could you imagine finding a bug in your favorite word processor and having a fix for it in a matter of hours? Because so many new versions of Linux are offered to the public, Linus has instituted a kernel numbering convention to let people know whether they are getting a stable release or a developmental version. The version number of the kernel is always in the form of 1.x.y. This is where x and y are numbers. If x is an even number, the kernel is intended to be stable. If x is an odd number, then it is a developmental version. Most versions of Linux are quite stable, developmental or not. In other words, what I'm saying, it isn't that dangerous to stay on the bleeding edge. Historically, people used to take a Linux kernel and gather different pieces of software from here and there, and they put together their own software system. While some may look back on this romantically, this was time-consuming and complicated. To alleviate these repetitive tasks, people have developed what are known as distributions. A distribution is a collection of software consisting of the Linux kernel and all the support programs needed to constitute a useful Unix-like system. All distributions are called Linux, but the consumer must remember several things. Different distributions contain different support software. The kernel is likely to be different. Also, one of the key differences is the method of installing Linux. Installation varies between distributions. There are many different distributions. Today, we will be installing the Yggdrasil, the Red Hat, and Slackware distributions. These are the more popular distributions. Well, just what does Linux give you? Well, it gives you true multitasking, which is the ability to run multiple programs at the same time. It is multi-user, in other words, several users on the same machine at the same time. And Linux runs in the protected mode with memory protection between processes. In other words, one program cannot bring down the whole operating system. For the technically inclined, Linux also has paged virtual memory, shared libraries, System 5 and BSD compatibility, 387 floating point emulation if you need it, POSIX job control, virtual consoles, and transparent support for many of the common operating file systems. I could go on. There are people who like to take the challenge of getting Linux to run on their own little small 2 meg 386SX computer with one floppy drive and a supported video card. However, to get real world work done, you're going to need a little bit more. Depending upon your needs, your wishes, and of course your budget, you'll probably want to go beyond the minimum usable configuration. If you're going to use computationally intensive programs, such as the X Window system, TeX, or the GNU-C compiler, you'll probably want to have a fast processor. You'll want to have at least 8 megabytes of memory to use X. One major difference that you will see with the memory under Linux is the fact that it does make a difference if you add more memory to your computer. It's not restricted to the 640 kilobyte limit as with other operating systems. So if you're going to use any of the popular distributions, you can assume that you will need about 200 megabytes of hard disk space to give you a system that you can use. This includes X. The real amount of hard disk space is dependent, of course, on what you want to install. Linux supports most SCSI and IDE devices. This includes hard drives, CD-ROM drives, and some of the tape drives. Most Super VGA, VGA, EGA, CGA, and Hercules video cards are supported by Linux. Most common networks cards are also supported. Linux uses TCP/IP networking, which includes FTP, Telnet, RLogin, NFS, SLIP, CSLIP, PLIP, PPP, and many other options that are available. Also, many sound cards are also supported. For more information on hardware, you will want to read the Hardware Compatibility How-To Guide, which is available on the internet and is also printed in a number of Linux books. This includes the Linux Bible. Most common Unix tools and programs have been ported to Linux. This includes almost everything from GNU. Many X clients have also been ported. Minor modifications to the source or to your make files are usually all that is required to porting software to Linux. Also, Linux has AutoConf and iMake to help make porting software easier. The number of applications available for Linux is enormous. All the basic Unix commands are there. Developers will appreciate the development tools available, from debuggers to compilers, C++ to Perl, and many other tools are available. Many X window managers are available. These include FVWM, TWM, OpenLook, and Motif. Many editors and text processors are also available. These include several versions of Emacs and VI. There are a number of shells, including the Born Again shell, the Korn shell, and T-shell, or the extended C shell. All your popular news readers and mail readers are available to you under Linux as well. And there are too many games to mention. However, I do have to mention the ever popular Doom. It's available on Linux as well. What I have mentioned is only a small portion of what is available under Linux. The sources for everything is available on archive sites all over the world, the most popular being sunsite.unc.edu and tsx11.mit.edu. There is an ever-increasing number of Linux users in the world. This is evidenced by the activity on the internet and on the news groups. Many small businesses have sprung up selling and supporting Linux. You can get support for Linux on the internet news groups under comp.os.linux. That's comp.os.linux, comp.os.linux. You should also read the Linux frequently asked questions, known as the Linux FAQ, which are posted on the Linux news groups. Any of the O'Reilly and Associates books on Unix-related subjects will be helpful, as the O'Reilly and Associates books are the definitive word on this subject. The Linux Journal is a magazine dedicated to Linux that has something for every level of Linux user in each and every issue. Technical support is also available. Yggdrasil offers technical support via a number of means. This includes a consulting hotline, business technical support, release on demand support, development contracts, and guaranteed technical support. Yggdrasil also produces its own Linux distribution on CD-ROM. This is known as the plug-and-play Linux. It also produces this video, the Linux Internet Archive Set, and the Linux Bible. So, where do you go now? Well, you could get Linux from the previously mentioned FTP archive sites, but this would take some time. So it's probably in your best interest to get a distribution on CD-ROM. You would also want to be sure to read the how-tos and the Linux frequently asked questions. Before we go on to the installation and setup of Linux in a few minutes, users must make some decisions before they install. These decisions are common to all distributions. First, you need to determine how you want to install Linux. Do you want to install it on top of a DOS file system, or do you want to partition a hard drive for Linux? Do you want to have multiple operating systems available at boot? And just how much hard drive space are you willing to devote to Linux? First, I do not recommend installing Linux on top of your DOS file system using UMS-DOS. I recommend partitioning your drive and devoting partitions to Linux. This will mean that you will need to back up your data already on the drives. This is because fdisk will destroy your data. There is a non-destructive tool for partitioning your disk called FIPS, or FIPS. However, I do not recommend this. The reason that I do not recommend installing on top of DOS or using FIPS is due to problems that some users have reported. Next, I recommend devoting at least 3 hard drive partitions to Linux. That would be for your root file system, your swap partition, and your home partition. I recommend at least 200 megabytes of memory for your root file system, more if you can afford it. For your swap partition, I recommend at least twice the amount of memory that you have in your machine. That is, if you have an 8 megabytes of memory, you should have a swap partition of at least 16 megabytes in size. Finally, the amount of space for your home partition will vary depending upon the number of users on your system. For a single user system, 50 megabytes should do nicely. Now, these are just general guidelines and recommendations. However, the system is yours, and you'll undoubtedly want to tailor the system to your own needs. I'd like to thank you for your interest and participation. Now on to the demonstration of installation and setup of Linux using the Yggdrasil, Red Hat, and Slackware distributions. Okay, now we're going to go ahead and start to install Linux onto our machines. We're going to take a look at 3 different installations. We're going to first take a look at the Yggdrasil distribution, and then we're going to take a look at the Red Hat distribution, and then we're following that with the Slackware distribution. What is common in all 3 distributions is that it's my responsibility to install Linux onto the machine, and I need to know exactly what equipment that I have. So, for this demonstration, I have a 486 CPU by Intel in this machine. I have one of the new IDE CD-ROM drives by TIAC. I have a 3.5-inch floppy drive, and I have a 400 megabyte hard drive. I have a video card. The video card that's in this machine is by Diamond. It's a Diamond Speedstar. And I have a monitor that I'll be using here, a high-resolution Super VGA monitor. Now, I need to know all of this information to go ahead and install Linux onto my machine. I also need to know what type of mouse that I have. And in the case of this machine, I'm using a Microsoft compatible mouse. And it is your responsibility what hardware that you have available and the information concerning that. You can find that information in the specifications and manuals that come with your system. If you do not have a manual, you'll need to go ahead and call the supplier or call the provider or the manufacturer to find out the information as you're going along. So let's go ahead and prepare your system for installation of Linux. Now, it doesn't matter which version of Linux that you're putting onto your machine. The concerns are all going to be the same for the initial install. First of all, I recommend that you put separate partitions, that you partition your hard drive into separate partitions for the various operating systems that you have. Now, it is possible to put Linux onto your system on top of your MS-DOS and not have to repartition. However, there have been some problems noted when people install Linux on MS-DOS, and I do not recommend that you do that. So therefore, I recommend to go ahead and bite the bullet and to repartition your hard drive. Before you repartition your hard drive, it is wise for you to run some utilities such as scan disk and defrag, which will defragment your hard drive, and then use some type of backup utility to back up the contents of your on DOS and Windows or whatever operating system that you're using. And then at that point is to go ahead and reformat and repartition your drive. Now, if you're not familiar with how to do that, you can check any MS-DOS manual to tell you how to use the MS-DOS F-disk program to partition your drive. So, I'm going to assume that we have gotten that far. We have backed up our hard drive, and that we're going to go ahead and partition our drive and make certain decisions about how we're going to install Linux. The first thing that I want to do is I'll enter F-disk. Currently I'm in DOS, and I'll go ahead and type F-disk, and I'll go ahead and I'll show what partition information that I have. And at the current time, I have one partition set aside for DOS. I'm using 25% of the disk. In other words, I set aside 100 megabytes for MS-DOS. And that's what I have. The rest of the disk I'm going to install Linux on. So let me go out of here. And I'm back in DOS. First of all, I'm installing the Yggdrasil distribution. I'll insert the floppy disk into the floppy disk drive, and then I'll insert the supplied CD-ROM into the CD-ROM drive. Now what I need to do is simply reboot the machine by hitting Control, Alt, and Delete at the same time. Now I've restarted the machine by hitting my Control, Alt, Delete button, but you can either use Control, Alt, Delete, or you can go ahead and hit your reset button. And you'll boot up, and the first thing that you'll see is the screen introducing the Yggdrasil Linux product, and there's a lot of information that is presented to you on the screen. Basically, what you can do is you can press the various F keys to get all your options that you can view of what you can go ahead and enter for options. And you might want to investigate these options based upon what type of hardware that you have. For example, if I had a SCSI system, I'd go ahead and press F2 to see what SCSI options are available. In my equipment that I'm demonstrating here, I have an IDE CD-ROM drive, so therefore I'm going to press F3 to bring up those options. Here I can see that if I want my IDE drive to be recognized, I'll have to say that HDB equals CD-ROM. The reason why I say HDB is because HDB is the second disk, the slave disk, and that's how I have my IDE hard drive, CD-ROM drive set in this machine as the slave drive. So I'll go back to my main screen. Let's take a look at F4, the options available for the non-SCSI and the non-IDE CD-ROMs. These are very popular drives out there. We have the Sony CDU31, and this also takes care of the 33A CD-ROM drives. We have the Sony CD535 drives. We have all the Sound Blaster Pro compatible CD-ROM drives. We have the Mitsumi and the Gold Star and the Philips and the Aztec drives. And this screen shows you the command line options that you need to enter. Now, if you don't enter any option at this point in time, what happens is the Yggdrasil distribution will try to determine to the best of its ability what options, what hardware you have on the machine. Now, to speed up the search, you can go ahead and enter some of the information, such as, for example, back on F4. By experience, I happen to know that the Sound Blaster Pro CD search takes quite a bit of time to accomplish on the machine. So one of the little tricks that you can learn to do is that you can enter some of these parameters, say SBPCD, which stands for Sound Blaster Pro CD. I can set that equal to 0, which will turn off the search for that. So that's what we're going to be doing here. Okay, so my command line, the first command line always begins with the word Linux. And then I hit a space, and now I'm going to turn off the Sound Blaster Pro CD search. So I'll do SBPCD equals 0. I'm also going to turn off the Mitsumi CD drive search. as another example. So I do an MCD equals 0. And I'm going to tell the machine that my CD-ROM, the IDE CD-ROM that I have in the machine, is located as my slave drive. In other words, my second hard drive, or as a slave. So I'll type in HDB, which means that's my hard drive B, or my second hard drive, is equal to CD-ROM. And that's how I tell the system what's going on. Now I can key back and forth between all the various options. For example, I can go to F4 and notice that I can see what the proprietary non-IDE, non-SCSI CD-ROM information is, but it'll still keep the lines that I typed in, the command line, still on the screen, and I can enter information. So I can go back and forth between the various options, like here's the IDE controller options, or I can also go back to the main screen by just hitting F8. So that's enough information for us to go ahead and get started now. So I'll simply hit enter at this point in time, and the machine will go ahead and start looking to see what type of hardware that you have. Currently we're loading Linux. You're going to get a lot of information out onto the screen. You can follow along with that information is. You really don't have to be concerned with a lot of it. For example, right now, because I didn't say that ignore the Aztec CD-ROM drive, it's doing an Aztec CD-ROM search, but that doesn't usually take that long. So therefore, we're just going, this is just all informational, information being presented to you. There's not really much to be concerned with. You don't have to do anything at the present time. Really, this information is valuable to you if, for some reason, your system, you can't get it up and running and you need to get some tech support. Perhaps the person that's providing tech support to you will ask you certain information from these screens. Otherwise, just sit back, relax, and ignore this. Now here's the first screen that becomes important to you as a user. Right here is where you get to log into and begin either the installation of Linux, or you can take a look to see what is available in the Linux. So the first thing that you need to know is that here's where you type in either demo or guest or root or install. If I type in demo, I will see a demonstration of some of the capabilities of Linux under the X Windows system. When I type demo, I'll be asked for certain information such as the type of mouse, the type of video card, and the type of monitor that I have. And that way the machine can figure out how to set up the X Windows system to show you the demo. Guest, if you log in as guest, you'll be able to explore and experiment with the system to a limited ability. If you log in as root, you'll be the super user and you can do certain systems administration at the time. But what we're primarily concerned with is the first time install. So at this time, we're going to type install. We've hit enter. And now we're going to be prompted for certain information. Here we have the welcome screen. It tells us that we can abort the installation at any time and exit by pressing escape. So otherwise we're going to be using the up and down arrows, and we're going to be using the arrow keys to navigate through the list, and we'll press space to toggle on and off options, and we can use the tab key to select between the various options at the bottom of the screen. So we'll go ahead and say OK here by pressing the enter key. The first screen that you're going to see is it's going to ask you what type of keyboard you would want that you're using. For this demonstration, I am using a United States keyboard. But if I wanted to change keyboards, all I'd have to do is navigate up and down with the arrow keys. And for example, if I wanted to select Danish, I would go to that, and then I'd press the space key. Notice that the indicator has moved saying that I want to install a Danish keyboard. So let's go ahead and make sure that we go back to the United States. I'll hit the space key at this time. And now my keyboard will be for the United States, and I'll go ahead and press OK by hitting the enter key. Here I can name my system. We're going to go ahead and use the default name Linux here. However, you can name your system whatever you like. For example, foobar, whatever you perhaps want to enter your system domain name here if you have a system domain name. Okay, here are some of the install options that we have that the Yggdrasil distribution presents you. We can auto mount our CD-ROM drive on boot. We can activate the guest account. We're going to go ahead and use the default options that are available here. But if you want to, for example, you can navigate down using the arrow keys down to make boot floppy. Just go ahead and toggle on by hitting the space key. But we're going to just use the default options. So we'll hit OK by pressing enter. Now, this informs us that we're going to install a minimum 10 megabyte plug-and-play Linux configuration onto our hard disk. And we're going to install everything except for what's under /USR. So the first thing that we're going to do is partition our hard disk. And we're going to designate the partitions for the root, also known as the slash file system. And optionally, we're going to put on the swap and personal directories, which come under the home partition. That is optional. However, I do recommend that you do that. I recommend that you minimally have a root file system, a swap partition, and a home partition. So we'll go ahead and proceed by hitting the enter key. So now it's asking if we should now partition our hard drive. It's telling us that. And we should create a root partition to hold our files, as well as a swap partition and a home partition for our personal files. So it's going to run fdisk on /dev/HDA under Linux all of our devices are under a /dev directory. HD means hard drive, and A is the first hard drive. HDB would be our second hard drive, and so on. So we want to run, because we only have one hard drive in here, on our first hard drive, which is /dev/HDA. That's where we want to run our fdisk on. Now this is not the same as DOS's fdisk. This is Linux's own fdisk. So we'll go ahead and begin the partitioning now by pressing OK. Now here's an informational screen. It's saying that we're running fdisk on /dev/HDA. Once again, this is our first hard drive. We can press M for help. M means menu, and I'll do that now. Press M and enter, and I can see all the different options that are available for me under Linux's fdisk. Let's go ahead and print out what the partition table looks like at the present time. That's P. And when I hit P and enter, I get back the information that /dev/HDA1, that means hard disk A, they're our first hard disk, 1, the first partition. I can see that under the very last column to the right, that it is a DOS 16-bit system. So in other words, I have DOS as my first hard drive partition. What now I want to do is I want to add other partitions so that I can install my Linux on. So as I can see above, N will add a new partition. So that's exactly what I'm going to do. I'm going to press N here, hit enter, and it's going to be a primary partition, so I'll hit the letter P, indicating primary. Then it's going to ask which partition number do I want to set. Now be careful here. If I hit 1 here, I'll wipe out my DOS partition, so I have to be particularly careful here. My Linux partitions are going to be 2, 3, and 4. And I have to remember that. So I'll enter partition number 2. Now it comes up with what my first cylinder I want to start my Linux partition on. I always start at what the first cylinder listed is, which is 205. Next, it wants either the last cylinder or the size in megabytes or kbytes, which is megabytes or kilobytes of memory that I'm going to be taking up a hard disk space. So I have decided that I want to set aside 280 megs for my Linux root partition. I recommend that you have at least 200 meg for any Linux system that you're going to be installing on. You should at least reserve 200 megs of root partition. So what I'll do here is I'll enter a plus, and I'll hit 280 capital M for megs, so 280 megs. Now I'll hit enter. Now if I hit M for help and I press P for the partition table, we can see that we have HDA1 is a DOS partition and HDA2 is a Linux partition, and of approximately 280 meg in size. Okay, the next thing that I want to do is I want to add a swap partition. The swap partition, the recommended size for a swap partition is twice the amount of RAM that I have in my machine. In this case, I have 16 megs in this machine, but what I really don't need to have that large of I don't need to have a 32 meg swap partition in here. So what I'm going to do, just for demonstration purposes, is I am going to put in a 10 meg swap partition. So I'll hit N for new. It's going to be a primary partition. It's going to be partition 3. Remember, 1 is DOS, 2 is my root Linux partition, and 3 is going to be my swap partition. My first cylinder is 774, and I'm going to say that I just want a 10 meg swap partition. Like I said, it's a good idea for you to go ahead and set up to have a swap partition size twice the amount of your RAM. Okay, so I want to have my last partition. My last partition is going to be my home partition. This is where I keep my private files, non-system files, just files for my users. It's also going to be a primary partition, and this is going to be primary partition number 4. So my first cylinder is 795, and my last cylinder, it's okay because this is my final cylinder, my final partition that I'm going to be entering here. All I need to do at this time is just to hit what the last cylinder is. So in this case, it's 826. Now if I look at the partition table, I can see that I have HDA1 as a DOS partition, and HDA2, 3, and 4 are all Linux partitions. If I take a look at my help for fdisk, I can see that W stands for write table to disk and exit. What I'll be doing here is I'll hit W, which means to write the partition table out to the hard disk and exit back to the installation program. So that's what I'll do here. You can ignore the reboot to ensure the partition table has been updated message. The syncing disks means that it's making sure that the disk information is synced. And now we're put back into the installation script. And the first thing it asks is, where do we want to have the root partition put on? And it has by default /dev/HDA2, which if we look, that was exactly where I wanted to have the root partition. If it was some other partition, then you could go ahead and edit this and make that the root partition. But this is, I'm happy with this, so I'll go ahead and hit enter, and that'll be okay. This next screen, it's asking us to set up our swap partition. Now the swap partition is used basically for administrative purposes for the Linux operating system itself to use. It uses it to swap in information and out information, such as virtual memory and etc. Things like that. And that's what the swap area is used for. The larger the swap area that you can go ahead and set aside, Linux is going to go ahead and use it efficiently. Like I said, once again, the recommended swap size is approximately twice the memory that you have on board. However, for this purposes, for this demonstration, we've set back just a 10 meg partition. Our next partition that we're going to set up, like I said, is the swap partition. It's asking us which is the swap partition, and I need to enter that now. It is /dev HDA3. Be very careful as which one that you're designating as what. We've already set up HDA2 as our primary root partition. Now we're setting up HDA3 as our swap partition. If you were to type in some other partition except for this one here, such as HDA1, we would overwrite our DOS partition. So we have to be extremely careful when we're entering these parameters here. So I'll press enter, And it's asking us which one that we would like to have as our home partition. And it's defaulted to HDA3, but that was our swap partition. So I need to correct this. I need to backspace and I'll hit HDA4. Once again, that's hard disk drive A, which is our first hard disk drive. And this is partition 4, and that's going to be our home partition. Press enter, which will activate the OK. So it's saying here that it cannot mount our home partition, and should I run mke2fs on it? What that is, that's a utility to format that partition. E2fs stands for the second extended file system, which is the default file system that Linux uses. So what mke2fs does is it formats the partition to be a Linux partition, and all data will be destroyed on that. And of course, we're just installing it, so that'll be fine. So we'll hit OK and return for yes. And now comes some more information screens. It's just telling us that it is, in fact, formatting the hard drive, partition 4. So it has set up our swap space for us. It has run mke2fs. In other words, it has formatted the hard drive for us. And now it is asking what type of system do we want to go ahead and put onto the hard disk at this time. Later on, we're going to be adding and maybe possibly even removing we're going to be adding packages later from the control panel. At this time, we're going to go ahead and enter the recommended packages. We hit the enter key, and with a lot of activity from our CD-ROM drive, we're going to go ahead and start. The CD-ROM will transfer information to the hard drive. Here's another screen that is going to show the activities that are happening. It's going to show that we have a bar graph, and it will show how much of the system that we have that we're installing. And it's informing us that in case it takes long enough, the screen blanker will come on, will blank out the screen. Don't be concerned. Just reach over and hit the shift key, and the screen will come back on. Okay, we're back, and we can see that the installation has come to its completion here for installing the base system at this time. And now it's going to go into configuration of the kernel. And now it's going to go into the installation of all the software packages under the recommended that you chose earlier. This is going to take quite a while. So go ahead, relax, and get a cup of coffee, perhaps a good book. And I would highly recommend the Yggdrasil Bible. Kick back and read it. And every once in a while, you want to check in on this. This could take like perhaps an hour. It really does depend upon the speed of your system. So, like I said, take a relaxing break now. Okay, now we're back from the installation, and now we're creating some symbolic links, and this is going to take a while. The symbolic links are done now, so it's telling us that to remove the boot floppy so that we can reboot the system, and that's exactly what we're going to do. So I've taken out the boot floppy, and I press OK, and the system is now going to reboot. It's sending the information that it is terminating processes that are going on, and now the system is going to reboot. Here it reboots into its BIOS checkup. And here we are, we are booting up to our boot selection here. This is known as Lilo, or the Linux loader. I could select from which partitions I wanted to boot from. For example, if I would have typed HDA1 there, which is the first partition, we had DOS on that partition, and I would have booted into DOS. However, I didn't do anything here, and it just went ahead and loaded into Linux automatically for me. Now, if I want to, I can go ahead and change the boot order so that it will go ahead and boot into DOS for me by default. I can straighten all this out in a file called the Lilo, that's Lilo, .conf, that's CONF file, the configuration file. And in the Lilo conf file, I can set the order of which operating system do I want to go ahead and boot by default. So right now we're going ahead and once again it's going through checking the system. It's going to find our hardware and it's going to boot for us. And our CD-ROM is mounted. And now it's doing some post-installation setup, and this will take some time, but you're never going to have to repeat this again. Okay, now that the post-installation cleanup has been done, you're now at a very familiar login screen. You'll be presented this each time that Linux is brought up. And here we can log in as a demo, which will run the demonstration for us, or we can run as a guest, which is an underprivileged user account that you can use to explore the system, or you can go ahead and log in as root, which is the super user account that you will use for doing systems administration. At this point, we're going to go ahead and install X Windows. So what we need to do is log in as root. And now we simply have to type in start X. This will bring up the X Windows system, but first it's going to run through a number of dialog boxes, and we'll have to answer questions concerning what type of video card that we have, primarily concerning what type of graphics chip is on the card, what type of mouse we have, and what type of monitor we have. Now, here's a little suggestion. Let's back up from StartX here. If I do not know what type of video card or chip that I have, instead of having to tear it out of the machine, opening the machine, I can type Super Probe. That's with a capital S and a capital P. This utility will go ahead and try to figure out what type of video card and video chip that we have. And you see that it comes back, and it says that we have a Super VGA card, and the chipset on it is a Cirrus CLGD 5434, and it has 1024 kbytes of video memory, and it has a RAM DAC on board. You should perhaps write this information down because you'll be using it later to install X Windows. So now we're ready to go ahead and start. I know that I have a Microsoft mouse, and I'm going to be using Super VGA. So I type Start X and hit Enter. The first dialog box that's presented to us is what type of mouse that we have. We can scroll through the list, and by default we have the Microsoft Serial mouse that's been selected. That's exactly the type of mouse that I have, so I'll just go ahead and press Return here. In this dialog box, it's going to ask where our mouse port for our Microsoft Serial mouse is going to be at. On the left-hand side, you'll see TTY S0 through S3, which matches COM1 through COM4. So my mouse is on COM1, or in the Linux world, TTY S0. And so I'll just go ahead and press OK here. If your mouse is on some other port, you would want to toggle down and select that port by hitting the space key. I'll go ahead and press OK now to select COM1. Next, it wants to know what your mouse baud rate is. Most common, if you don't know what your mouse baud rate is, it's most common for your serial mouse to be 1200 baud. So I'll go ahead and hit OK here by pressing the return key. Now here's where it comes into selecting your video card. Notice if the video card doesn't appear here, we can try selecting Other. And this information will have to be supplied by the user, and it might not work with all configurations. So if this doesn't work here, we'll go ahead and I will tell you later how to deal with any problems that happen if this doesn't work the first time through. I have a diamond card in here, and I can scroll through and see the many different types of cards that we have here. As you can see, there are many different options here that I have. But I want to go ahead and I'll select the diamond card that I have. I have a Diamond Speedstar. So I'll select OK here. And here it wants to know what video modes that I want to have available to use. Okay. Now, I need to select video modes that my monitor will be capable of handling. I can find this information out by looking in the documentation that comes with my monitor. This is something that you need to pay particular attention to. If you select a video mode, like a high resolution mode, that your monitor is not capable of, you might damage your monitor. So be very, very careful with this. I happen to know that my monitor can handle the 640 by 480, the 800 by 600, so I can hit the space to toggle that option on, and the 1024 by 768. So I'll hit the space bar to toggle that on. I'll press OK. Now it wants to know what type of monitor that I have here. The monitor type that I have is not on here, so I'm going to select Other. Now the X server needs to know the monitor bandwidth. You can enter this data into here. You look for it in your monitor's documentation, but I'm going to go ahead and use the default mode, let the computer figure it out. And the horizontal frequency, I'm going to go ahead and just use default values for it also, but you can enter this information from your monitor's documentation. And the monitor the vertical frequency you'd also find from your monitor documentation. And here, once again, I'm going to enter just the default values by pressing OK and not entering anything. What the computer has just done, it has created what is known as an XF86 config file. And now it is attempting to bring up X windows for us. Notice that I have the cursor, the mouse cursor. It's able to move around. Therefore, I've selected the correct mouse type and mouse port. That's a good indication there. Now what's going to happen is that a number of windows are going to appear. First of all, the window manager is going to appear. This is known as FVWM. That's the F Virtual Window Manager. Some people call Fred's Virtual Window Manager. And that's the first thing that you're going to see. This is the window manager that we're going to use. There are many different window managers available under Linux. For example, TWM, GWM, and Motif. The Motif window manager is available for commercial sale. What we're going to be presented with is a number of X terminal windows. There's going to be XFM, which is the X file manager, which gives you a window in which you'll be able to do drag and drop and various administration functions. You'll be presented this control panel. Okay, here's the file manager, and here's an application manager. The file manager I can navigate through my directories with. And this is a very highly customizable environment. This file manager window, along with this applications window, is part of what is called the XFM, and it is highly configurable. So you need to see the documentation on that. What's important at this time is the control panel. This is very unique to the Yggdrasil installation program. As you can see here, we have the name of our machine, and we can name a mail server up here, a news server I should say, and down here are various buttons to accomplish various administration tasks. For example, if I click on this button, the optional software packages will come up. I'm able to administer networking very simply by clicking on this button. Doing a serial internet connection brings up a form which allows me to do a slip connection by simply filling out the information in the form and clicking on the OK button. I'll be able to set up a slip connection very easily. I'll bring up this form at the present time. You see right here we can set up a serial internet link, a slip connection, very simply by entering the phone number, the address of the remote end link, the address of our link, what serial port we're going to use by calling out, what modem that we're going to be using, in other words the modem port, the baud rate that we want to communicate at, the login prompt, our username, password, etc. like that. If I just go ahead and set save right there, this will go ahead and build the files that will allow me to, when I log onto my machine, I turn my machine on, because of the activate serial connection at boot, when I turn on the machine, it'll go ahead and dial into my internet provider and set up a serial link, a serial internet link via slip to my internet. So I'll be right onto the internet as soon as I log in. Another thing that I can do is I can easily configure my printers by bringing up a printer dialog. Here I can go ahead and name where my printer port is. Notice that I get online help in the pink area here for each thing that I do. I can do a remote printer, and then I can select what type of printer that I have through this scrolling list of printers. All I have to do is merely select which one, and it will go ahead and set up my print files for me. One of the most important buttons on this control panel is the optional software packages. If I click on this button, this is what brings up the form of all the optional software that I can install from the CD-ROM onto my hard drive. The reason that I want to do that is that it will cause the software to run faster instead of having to run it directly from the CD-ROM drive. So here's the window that we're going to bring up, and it shows a number of icons on here. If I go to any of the icons, you'll notice at the top there is an explanation of what that icon is for. For example, I go over to editors. It's the parent component for text editor programs such as Emacs and VI. There's games, sound, administration, development tools, etc. You can go explore any of these at your leisure. Let's go ahead and let's take a look at the COM programs. What I can do here is I can install the whole package by simply clicking on that package, or what I can do is I can select individual programs to install by double clicking on the icon, and it will take us and show exactly what is available under the COM communications package. We have eFax, which bringing the cursor over to any of the packages will show you at the top exactly what is in that package or what the function of that package is. Let's take a look at eFax. It's a program to send and receive faxes through a fax modem. If we want to install that, we just have to simply click on that. Minicom. Minicom is a telex-style terminal program that can be used to dial out on a serial line. That's very useful. So This is what we can go ahead and use to install these packages with. Here's Lynx, which is a text-based World Wide Web browser. Very nice. When we're done selecting and installing various options, we can go back to the main control panel. Installation for the optional software packages by simply clicking on the arrow. And we're going to be back again, once again, to the main window for optional software. Let's go ahead and look at, for example, development tools. We can double click on development tools, and you'll see all the icons for various development tools. Let's go ahead and look at tools for debugging. I can go ahead and double click on that, and it'll bring up all the different debuggers. So here's, for example, electric fence, expect, gnats, deja nu, the popular GDB, and strace. These are all programs that you can install. So this is how you explore the packages that you want to see that are available and how to install them by just simply clicking on them, or by passing the cursor over the icon. It will give you the information of exactly what the program is for, what it does. Here's emulators, which will allow you to install like the DOS emulator, the Microsoft Windows emulator, or the IBCS2 Unix systems emulator. These are very powerful tools that are available to you. So feel free to investigate, to double click on these, to determine what you want to install onto your system, to customize the system for yourself. And basically that's it. That's exactly what you want to accomplish. This is exactly what you want to do with your Linux system, is to customize the system for your needs. And this control panel gives you that capability. So when I'm done doing whatever I want, I can save or I can quit from here. Under the XFM file manager, I can go and I can select applications. For example, I'll select my printer. I can drop documents onto my printer to print, etc. So full drag and drop. I can read my mail by double clicking on my mail utility. It'll bring up Xmail. If I had mail, if I have mail configured, I can go ahead and do my mail from here. And there are many utilities. This is highly customizable. You can customize it to exactly what you want it to do. It's very easy. In the back of the Yggdrasil installation distribution manual there is a copy of exactly what all the programs available are and the descriptions of them. So this basically ends this portion of the installation process and setting up X Windows using the Yggdrasil distribution. In this next portion, I'm going to demonstrate the installation of the Red Hat distribution. Red Hat, each distribution takes a little bit different approach to doing installation. That's the primary difference between one distribution and the other. So we're going to take a look at the Red Hat distribution here. I am back again to DOS. I have made the determination that using fdisk, my DOS fdisk, I'm going to head and look at the partition, and I have once again only one DOS partition that is taking up 100 megabytes on my hard drive. The other 300 or so megabytes of hard disk space I'm going to put my Linux distribution. In this case, it's the Red Hat distribution. I'm back at my C prompt. What you have to do with the Red Hat distribution is that you have to make 3 disks. What you have to do is you have to format a 3.5 inch disks. You insert your CD-ROM, and now I'll go to my CD-ROM drive, and I'll list the contents of the drive, of what's on the CD-ROM. And if I go to the DOS directory, and I list its contents, I can see that it has a number of utilities on here. Most important to us at the present time is the utility rawrite.exe. That's rawrite.exe under the Red Hat CD-ROM DOS directory. Next important directory that should concern us, so I'll back up to the root of the directory, take a look at it again, and I can see the images directory. These are the various Linux kernels that we'll use to boot. We need to figure out which kernel is appropriate to us and put that image onto one of the disks. So the first thing that I need to do is format 3 floppy disks. So I have already done this. I have 3 floppy disks, 1.44 meg floppy disks, 3.5 inch in size. I've formatted them, and now I will go ahead and put the images that I need to put onto these disks. What I need to do is first determine which image that I need to put on. I can do that by changing to the images directory. I'll list the contents here. Notice that there's a directory called 1213. We need to go to that directory. Those hold the kernel images for Linux kernel number 1.2.13. I'll list the contents of this directory at this time. And you'll see listed here are a number of boot images. Each one of these boot images contains configuration of a kernel that probably will match one of your systems. Now, let's go ahead and take a look at the file image.idx. I'll go ahead and use the DOS program edit to view this file. Here it shows in the left-hand column the last 4 numbers of the boot images of the files that we just saw earlier. On the right-hand side is a description of what type of system that we're going to install it onto. For example, if you look at the very first line, it'll show that it has IDE/Atapi or SCSI. In other words, if I take the boot image boot 0000, I will be able to utilize that boot image on a system that has an IDE CD-ROM drive. That's exactly what my system has, and that's the one that I will use. The second column, if you notice, says none. That's because the second column indicates if it has a SCSI adapter of some sort. In my case, on my system at the present time, I have no SCSI drive. The third column, which also says none, is a column that indicates what type of networking card that I have. So, if I have a network card and or a SCSI card along with my CD-ROM drive, I would need to go ahead and preview through this list to make determination which kernel that I need to go ahead and use. In our case, we're pretty lucky because it is just image 0000. So knowing that, I'll exit the edit program. And now I need to put this boot image onto my floppy drive. So I'll insert a disk into the floppy drive, and to make the image, I need to, in other words, to transfer the image, boot 0000.image to the floppy drive, I need to use the DOS utility rawwrite, which was located on the Red Hat Linux distribution CD-ROM under the DOS directory. So I can do that idiskd /DOS/rawwrite. The first thing that it wants to know is what disk image source file name do I want to lay down onto the floppy drive. I type in boot 0000.img, and then I say what disk drive do I want to write to. In my case, my 3.5-inch disk drive is drive A. As soon as I hit enter, the image, the boot image that I have selected, will be written down onto the floppy drive. Now that I have the boot disk prepared, I removed it from my floppy drive. It now has the boot image on it, and I clearly label it to be the Red Hat boot disk. Make sure that I clearly label that. The next task that is needed, I need to create 2 more disks. That's why I told you earlier to prepare 3 formatted, DOS formatted floppy drives. So I'll move from the current directory, which is on the Red Hat CD-ROM images/123 directory. I need to back up one directory, so I'll do a CD space ... which will move me back one directory in DOS to the images directory. If I do a listing here of a directory listing, I'll see 2 files, ramdisk1.img and ramdisk2.img. I need to put each one of these image files onto one separate disk. In other words, I'll put ramdisk1.img's image onto one floppy disk, and then I'll put ramdisk2.img on the second floppy disk. I'll be using the rawwrite utility like I did previously, and after I'm done, I'll label the disks Red Hat Ramdisk 1 and Red Hat Ramdisk 2. Now all of this is in the Red Hat distribution installation manual. So once again, I'll access the rawwrite utility, which is in the Red Hat Linux distributions DOS directory. It's going to ask me which image I want to write to the floppy. It'll be RAM disk 1. 2.img, and it'll ask me what target drive. I'll enter the target drive, I'll go ahead and do that, and then I'll repeat this process again using raw write to the second disk, and I'll use the image ramdisk2.img. Now that I've made all 3 disks for the Red Hat Linux distribution installation procedure, the first one I had made was the Red Hat boot disk from the boot images, and then I made ramdisk1 and ramdisk2 by using the raw write utilities in all 3 cases. Now I'm prepared to do the Red Hat installation. I insert the Red Hat boot disk into my primary floppy drive, and I reset my machine. Control-Alt-Delete will do. And here it's goes into the Lilo boot prompt, and what we do here is we enter some information according to what's on the screen. For example, I say that I first give the word Linux, and then I go ahead and say HDB, which is my second hard drive. In other words, hard drive B is equal to a CD-ROM. That's because my IDE CD-ROM is set as the slave on my IDE. So it becomes HDB equals CD-ROM for that reason. I hit enter, and now we'll go ahead and load Linux, and we'll simply follow the directions on screen. Notice now that it's asking us to insert a RAM disk floppy. I'm going to eject the boot disk that I created, and now I'll insert RAM disk 1 and press enter. Now that RAM disk 1 is done loading, it has asked me to insert RAM disk 2 floppy, so I'll eject RAM disk 1, set it aside, and put in the RAM disk 2 floppy and press enter. And I'm brought to my introduction screen to the Red Hat Commercial Linux installation program. So I'll press enter here, and now it has asked me to remove the root 2 floppy and to reinsert the boot floppy. That was the very first floppy that we had made. Press enter. And it asks us now if we want to do an express install, which would be the simplest installation. And for this, we do want to do that for this demonstration. It's asking if we're going to be doing an FTP installation. That's using the FTP file transfer protocol, and we're not going to be using that in this example. We're going to be installing from the CD-ROM. We're going to answer that no. We'll move to no. We can do one from the X graphical installation, or we can do a text-based install. We're going to go ahead and take the graphical installation. Now, if we're using OS2 as a file system, as one of the operating systems on our computer, we need to use, and we want to use the OS2 boot manager, we need to take special precautions and special considerations. In this case, since we're not using OS2, we can go ahead and just continue here. Now, we have to have one or more free partitions for our Linux file system. So once again, we're going to go into the Linux fdisk, and partition our disk, and that's what we're going to do now. Each partition used for Linux has to be set up as type 83. We'll look in that in a second. And our swap partition we want to set as type 82. We'll also look at that, what we're talking about there. Okay, we have found the following disk, /dev/HDA. Well, what we're going to use is we're going to use fdisk to partition our drive with. We'll press enter here, and it asks which disk that we want to partition, just in case. Now, at the bottom of the screen, you'll see the command, and we'll hit M for help. M stands for menu. At this time, we'd use the fdisk utility just in the same way as we did in the Yggdrasil distribution. So let's go ahead and move on. We're done partitioning this disk, so we'll toggle down to done using our arrow keys, and then we'll hit enter to enter OK. And if fdisk complained not being able to reload the partition, we can reboot now. But we're going to go ahead and continue the installation process. It's looking for the swap partitions, it found the swap partition, and it's confirming that we do want to use HDA3 as a swap partition. So it's formatting HDA3 for swap space. And it wants to know if we want to configure networking at the present time. If you would hit yes, you'd be put into a number of dialogues that would ask you for networking information, such as your IP address, etc., like that. But we do not have an Ethernet card on here, and we're not going to set up this system for networking. So we're going to answer this question, no. I toggle over to using the arrow keys to the no, and I press enter. And it's asking where I'm mounting the Red Hat distribution. I'll be using the CD-ROM, but it is possible to do network installation. It has found successfully that the Red Hat CD-ROM and the second drive on the primary IDE interface, which is on device HDB. It's asking if that's correct. And then it asks, what type of mouse do I have? I have a Microsoft Serial mouse. And it wants to know what port that I have. And it is indeed on COM1 or /dev/TTYS0. It wants to know what type of video card do I have. I'm going to use a generic SVGA. And it wants to know if you want to do an auto probe to determine your clocks. We'll go ahead and say yes. And it has correctly found our chipset. And it has correctly identified the amount of memory that's aboard. And it has identified what it believes to be the clocks. We can answer yes to that. And now we can check, select some type of monitor that we have, and the generic multi-sync. I want to select the 640 by 480, and I want to do the 800 by 600 mode, and I want to do the 1024 by 768 mode. It asks which one I would like to start in. I prefer the higher resolution mode. Wants to know how many buttons are on my mouse. And it's about ready to start X. And now it's going to go ahead and
bring up the installation. It wants to know what partition, root partition, will form the base of the Linux file system. And we said that it was going to be HDA2. So notice HDA2 has been set aside for the root. That's known as the mount point. And we're going to select HDA3. We're going to edit this information. We want its mount point to be the home directory. So we set aside HDA4 for. Notice that that's how we set everything. We can go ahead and say that we're done with that. And would we like to format these partitions? Yes, we would like to format both of them. So now it'll go into the formatting of HDA2, which is our root partition, and HDA4, which is our home partition. Here, the Red Hat distribution scans the disk for the available packages that are able to be installed. Red Hat uses what's called RPM, which is the Red Hat Package Manager. This RPM allows a user to install or deinstall software from their disk. So now this is what Red Hat goes to. It wants to know what parts you would like to install. The basic system will be installed automatically. And if you don't want the complete installation, you need to customize it. So this is what we have available to us here. What I would like to do at this time is we'll turn some of this off. We'll turn the development and documentation off and games off, and we'll just have X Windows, X applications, some other applications, and games installed right now. We'll go ahead and click on Done. And now we'll go ahead and it'll do the installation process to install the rest of the system at this time. So this is going to take a little while. So once again, kick back, read the documentation manual from Red Hat, and find out more information about your system. Okay, well, now we've finished the installation. That took a little bit of time, and now we're going to go ahead and copy the kernel to the hard drive. And we'll go ahead and set our clock to local time. I believe it's set to local time, but we can always change that. And now it asks what time zone that we're in. We're in US Pacific. And now it asks what type of keyboard map that we want. We want the US key map. And it now wants to know where we want to install Lilo, which is the Linux loader. And by default, it's on the master boot record of /dev/HDA, which once again is hard disk drive A. So we'll go ahead and say OK on that. And it wants to know if we need to specify hardware parameters on the Lilo command line to boot the installed disk. These different special hardware parameters are, for example, like the geometry of the disk drive, for example. We don't need to do that here. So we'll answer no. and it wants to know if we want to boot other operating systems as well. And you can tell what partitions you'd like to be able to boot, and we can label them that we want to. Here on HDA1, which was the first partition on our first hard drive, we had DOS. So I can select that. And I can edit it, and I can call it DOS. I'll say that I'm done with it. And then the Red Hat lists out what the Lilo configuration file will look like. And wants to know what that we should do with this configuration. We'll do an install. What happens is that this configuration file will be used by the executable called Lilo, which will put the boot sequence on the master boot record for us. Now we need to pick a root password, and we'll just go ahead and use Red Hat in this for demonstration purposes here. Okay, now our installation is finished and we can reboot now. We'll remove our boot floppy at this time, and we'll go ahead and reboot the computer. And we're at the Lilo boot, which we'll just simply go ahead and hit the return key. Which will bring us right back into Linux. So it looks like everything went well during the installation. So yes, indeed, everything seems to have went well, and now we can go ahead and log in. I'll log in as root, and our password that we had given was Red Hat. Make sure that you have your own personal password. And we'll go ahead and begin X Windows by doing Start X. And here we are, we've successfully loaded Red Hat software, the Red Hat Linux distribution, and we see various utilities that we have available here. And here's Red Hat's control panel, which we can do file system configuration with. We can search our help systems to find out information. We can configure our network, and we can configure our printer. We can go ahead and set our time and date. We can set up a user and group configuration, and we can do package management, which means that we can install and delete packages as needed. And we can bring up various X windows, and we can see different modules that we have. And we have a clock, So we can bring up additional windows. And we can go ahead and we can exit from FVWM. That's the window manager that we're looking at right now. Okay, now we're going to take a look at the Slackware installation. The Slackware distribution was created by Patrick Volkerding, and the first thing that we need to do, we have to decide how we're going to partition our hard drive. I've already made that decision here. If we take a look at this hard drive partition using the DOS F disk, we're starting off in DOS, and we can go and look at the partition information by selecting option 4, and here we're inside of F disk looking at the partition table, or in other words how the hard disk drive is divided up, and we can see that our first partition is drive C, and it contains a DOS file system. It's 100 megabytes in size, and that is 25% of the hard disk space. As you can see below, the total disk space is 406 megabytes. So in other words, around 300 megabytes I'm devoting to Linux. So we can get out of FDisk by pressing escape. And one more time. And we're back to the familiar MS-DOS C prompt. The first thing that we're going to need to do is insert the CD-ROM into our CD-ROM drive. Now I have an IDE CD-ROM drive. It's by TIAC. It's one of the newer 6x or 6 times speed IDE drives. And I'll go ahead and change to that drive now. And we'll take a look at the directories at the root of the D drive, which is the CD-ROM drive, and we can see a number of directories. This particular CD-ROM, which has Slackware on it, which is a popular distribution available by many different vendors, this Slackware version is the one that is included on the CD-ROM on Yggdrasil's Linux Bible. So now we need to navigate to the Slackware directory. The Slackware directory is the SLACKWAR directory. So that's SLACKWAR. I need to change to that. Now I need to look at the contents of that directory. From here I can see a number of interesting directories. The ones that concern me are on this distribution, and every Slackware distribution you'll find similar directories. I want to go and look at the contents of the installed directory. And here I'll see two important files. One is gzip.exe and the other is rawwrite.exe. gzip.exe is a DOS utility that will allow me to compress and uncompress in the gzip format. Rawwrite is a utility that we saw in the previous installation, which allows us to write bootable images to a disk drive, which will allow me to boot from that disk drive. So this is the location of a few of the utilities that I will need to do the installation of Slackware. Also, you notice there is also a FIPS or FIPS directory. In that directory, you'll find a non-destructive hard disk drive partitioning utility. This utility has been out on the market for a number of years, and
Yggdrasil makes no guarantees on or takes any of the responsibilities of anything that happens using FIPS. But it is there, and people have had success with using FIPS. So now I'll go back to the Slackware directory, and I'll take another look at the directory structure. And I see that there are several other directories that I'm really interested in. One of them is boot dsks.12 and boot dsks.114. These two directories contain the boot images. In other words, it contains images that we are going to copy to a floppy drive. Now the boot disk.12 directory contains boot images for a disk if you have a 1.2 meg disk drive as your primary drive, or your drive A, your floppy drive A. Boot disks.144 is for the 1.44 meg drives. In other words, if I have a 1.44 meg floppy drive as my drive A, I'll want to go to that directory to get my boot images. Also, there are rootdisk.12 and rootdisk.144 directories. These directories contain the root disk that we are going to have to make. And once again, the rootdisk.12 directory contains the root disk image for the 1.2 meg floppy drive, and the rootdisk.144 directory contains images for making a root disk on a 1.44 meg floppy drive. What I need to do is go to the boot disk.144 directory. I'll get a listing of that directory now, and I can see a number of files under here. The IDE CD file is the boot image file for your IDE CD-ROM drives, and the IDE CD.gz is a compressed version of that file. You would use the gzip utility to uncompress that file if you needed to. However, the IDE CD file is an uncompressed version of the IDE CD.gz file. So which one of these images will I need to put onto my floppy drive? This file, which is called which.1, or which one, will tell you which one of these images you need to put down onto the root disk, or onto the boot disk, excuse me. We'll take a look at that file now. Now that I've brought up the which.1 file using the DOS edit tool, the first thing that it says here is there's a question. There are so many boot disks, which one should I use? Well, here's a little table that helps you decide, and we'll go ahead and scroll down through this list, and we can see all the various options that we have here. Now, I have an IDE hard drive, and my Slackware source is on an IDE drive. So if I look at here, which is the IDE drive, and I go under the column for, I'm putting it onto an IDE hard drive, it says that the kernel that I need to, or the boot image that I need, is the IDE CD boot image. So that's the one that I'll use. I'll get out of here and I'll go back to
seeing the IDE CD boot image, and the utility that I can use to copy the IDE CD boot image to my boot disk that I will be using to boot up into Linux for the installation, I can use the utility called raw write. We found the raw write in the directory install. Let me change to install. And there is rawwrite.exe. Now what I'll do is I'll go back to the boot disks. Now from here, I can go to the install directory and use the utility rawwrite. Now it wants to know what our source file will be. They're asking which boot image will I want to transfer to the floppy disk. I say IDE CD. And it wants to know what the destination drive is. I say A. Notice it says that it wants a formatted disk. Well, this is a DOS formatted disk. I'll put that into drive A and press enter. Now that I've done the transfer using rawwrite to the floppy disk with the image, in other words, I have made a boot image, I clearly label that as my boot disk, my Slackware boot disk. I clearly labeled that one. Next, I need to make a transfer of a root disk to my floppy disk. So I need to go to the root disk, and of course I have a 1.44 meg floppy drive, so I go to that directory. If you had a 1.2 meg hard drive, or 5 1/4 in other words, you would want to go to the root disk.12 directory. Here are a list of contents. Once again, I'll use the rawwrite utility, which is located in the directory below in the install directory, and we'll use rawwrite. Now it wants to know what the source file is. Well, once again, I said that was color 144, and it wants to know what drive. Once again, that's a 1.44 meg DOS formatted floppy. I'll put that into drive A, and I'll press enter, and it'll transfer color 144 image over onto the floppy disk. Now that I have both my root disk and my boot disks made using the rawwrite utility, and I have them clearly labeled as boot disk and root disk, at this point in time, I can go ahead and begin the installation of the Slackware distribution. I do this by inserting the boot disk that I've just made into my floppy drive A. And then I reset the computer. I can do this by pressing Control, Alt, and Delete, or by pressing the reset key. This will reboot the computer. You're going to see the examples here of we can enter information at the boot prompt here, and that's exactly what we're going to do. We're going to say RAM disk. We're going to enter the parameter that HDB equals CD-ROM. Do not be concerned with the information necessarily at this time that has been displayed on the screen. what has happened here, it has looked to find if we have had any SCSI drives. It was trying to find out what type of hard drives that we have and what the CD-ROM is. It successfully found the CD-ROM, and it also successfully found that we have a hard drive. Next, it is asking us to put the RAM disk, or what we call the root disk, in Slackware. Even though it says RAM disk on the screen, they are referring to the root disk that we made, the root disk floppy. I'll press enter. We need to log in as root, and we need to partition our hard drive using Linux's fdisk. So that's what we'll do first. We'll log in as root, and then we'll type fdisk. And the next parameter here that I'm putting in is I'm saying that I want to have the first, and in this case, the only hard drive on my system to be partitioned or looked at by fdisk. In Linux, or in any of the Unix-like operating systems, we do not use drive letters like drive letter C or D like in DOS. What we do is we use what are called the device names. Device names are found in the /dev directory, or the device directory under Unix. And HDA means that it's the first hard drive, or a hard drive A, the first one. So we are brought now to the fdisk prompt. At this time, we'd use the fdisk utility just in the same way as we did in the Yggdrasil distribution. So let's go ahead and move on. The next thing that we need to do is we need to begin installing the Slackware installation, and we do this as root by typing setup. It brings us to this dialog. This is the Slackware Linux setup dialog. You can navigate through this by using the arrow keys. The first option that you're able to use is the help option, where you can read about the setup help. And the key map, you can remap your keyboard if you're not using a United States type keyboard. In our case we are, so I don't have to do anything here. I can choose between quick or verbose install mode. At the current time we're in verbose, and the first time that you install Slackware, I recommend that you keep it in the verbose mode. Make tags is an expert's customization feature in Slackware. Experts can go in and customize what are called tag files to pre-select packages and options that they want to install. I recommend that you leave this alone if this is your first time. Okay, our next option is the add swap option, which we can set up our swap partitions. Now from this point on, Slackware pretty much takes you and handholds you from one section to the next, as we'll soon see. So this is what we want to do now. We've already set up our swap partition, and we set up the swap partition type to be of type swap. So we'll go to there by pressing the enter key. It has detected the swap partition because we set it to ID 82. So it's confirming that we want to install this as our swap partition. And here's another warning. If we've made any of our swap partitions active, then we don't want to allow setup to use make swap on our swap partitions. So, do we want to use make swap on our swap partition? The answer to this question is yes, because this is our first installation. And we haven't already activated our swap partition with swap on, So we need to do it this time. So it's asking if we want to activate the swap partition with swap on. Our answer is yes. Okay, so now it has added the swap space, it's configured it, and it has added it to our /etc/fstab file. The fstab stands for File System Table, and the entry that is listed below is what has been entered into that file system table. It has said that our third partition on hard disk drive A is a swap partition, and it's going to take the defaults. Now that we've set up our swap space, we want to continue on with the installation. We decided that /dev/HDA2 was going to be our root partition. This partition hasn't been formatted. It was partitioned but not formatted, so we need to format it now, and we'll do a quick format. It found that we had more than one partition as a Linux native file system, and so it's going to ask some questions about that. We already have HDA2 mounted as our / partition. This is known as our root partition, and so we want to mount our other large directories on separate partitions perhaps. That's why I said that we should put our home directories there. So that's what we're going to do. We'll answer this question, yes. And it wants to know which partition that we want to use. That's /dev/HDA4, which we're going to designate as our home partition. We'll want to format it real quick. We'll use the defaults. And partitions need to be mounted. We're going to put it in our home directory, so that's where we're going to mount /dev/HDA4 as home. That's how I designate that. And once again, this entry will be added into our fstab file, which is the file system table. Notice that /dev/HDA4 with the mount point of home, and it's an ext2. That means the second extended file system for Linux, and it's taking the default. And would we like to mount some more partitions? We can say yes to this. And here it says enter the partition you would like to use, or type quit to quit adding new partitions. So we'll enter Q here for quit adding new partitions. And it found that we do have a DOS file system on board here, and it wants to know if we would like to make some of these partitions visible from Linux. Well, that's a good idea. I can read and write to my DOS file system from here. And I'll be able to use the DOS emulator and use some of the files from my DOS partition, so I can make it available from Linux. So I'll answer this question yes. It wants to know which partition we want to access from Linux. In this case, there's only one. It's /dev/HDA, which is our first hard drive, and 1, which is the first partition on that hard drive. Now it wants to know where to mount this within our directory tree, to mount it under DOS C, because that's like my C drive under DOS, so that's sort of a remembrance I can use as DOS C. And once again, it has added that partition to our fstab. Now we don't need to enter any more partitions, so we can enter Q here to quit adding new partitions. And now that we've set up our target, that's where we're going to put Linux, it wants to know if we want to go on to the source selection and select our installation media. And of course we do. So we're going to install from a CD-ROM. So we'll navigate down to that selection 5, press the OK by hitting the Enter key. And we're going to install directly from the Slackware CD-ROM. And the type of CD-ROM that we have is the IDE interface CD-ROM, which is selection number 7. We press the enter. Well, ours is HDB, which is the primary IDE drive number 2. We can run most of the Slackware from the CD-ROM if we're short on drive space, or we just want to test out Linux. I don't recommend doing that because it runs rather slowly from the CD-ROM. You want to have a usable system, so you want to go ahead and do a normal installation to the hard drive. This is a term that Slackware uses. It's called disk sets, and we'll see what they are in a second. If I get to an option that I want to install, I can go ahead and press a space bar to toggle on these, so that will be selected. So let's say, of course I want to have the base Linux system, and for the sake of brevity, I am going to just select a few things here to install. I want to put the X Windows system because I want to demonstrate it being installed, and some X applications also. But there are many different things that I can select here, but I'm going to just select these few. Now that we've decided what we want to install, we can begin by moving to the installation section. The prompting mode, which is we just want to use the normal default tag files that are already present in Slackware. And you want to use this mode especially if this is your first time installing Slackware. Well, it's installing what is called Disk Series A because Slackware has the unique ability between all the distributions to be installed entirely from floppy disks. And the disk series, you can have like, which A1 would fit, are files that would fit onto one floppy disk. In the upper right-hand corner, you'll see a priority listing. It'll say priority required, or priority recommended, or priority optional. Right here, it's asking if we want to install a kernel version that doesn't have SCSI support right here. The options that I have, I can use the arrow key to go between either yes, install the package, or no, do not install the package. Notice here, you have to install one kernel. Wants to know if we want to do IDE support with SCSI here. We don't need this one right here because we don't have SCSI on ours, so I'll answer this no, do not install. One of the hardest things about the Slackware distribution is setting on your hands, because at times after hitting the enter key a number of times, when you see a screen, you'll have the tendency, a lot of people do, to hit the enter key. If it's on a screen that is not asking you to install or not to install, or to install, which is giving you an option to do so, if you press the enter key gets buffered, and so the next time it is looking for an answer from you, it will assume that it already has the answer, and it will go ahead and install that package or do something that you don't want to do. So my recommendation is to take your time with Slackware and learn to set on your hands. And now you want to answer each one of the dialog boxes with the appropriate answer. But for the sake of brevity, we're going to fast forward to the selection of the X server that is appropriate for your machine. Now we're going to go into installing Disk Series X. We're going to be asked which server that we want to install. Now, I have already used, I already know what chip set is on my card, and so I'm going to use the Super VGA server. So I do not want to install this server. There are several servers on here that the Slackware installation will ask you if you want to install that server or not. So no, I do not want to install this server. It wants to know if I want to install this server. No, I do not. It's not the type that I want to install. It's asking if I have a Mach 32 chip. No, I do not. I have a Mach 8 chipset. No, I do not. Wants to know if I want to use it as a monochrome server. That'd be pretty boring, so no, I don't. Wants to know if I'm using a P9000 chipset. No, I'm not. Wants to know if I'm using an accelerated server for cards using the S3 chipset. No, I'm not. You can find out what chipsets that you have by looking at the card or by looking in your video documentation, your video card documentation. Now this is a super for just super VGA cards. That's what I will go ahead and install here. Wants to know if we want color icons. That would be nice. And now we'll be going back to answering individual dialog boxes with the correct answers, but for the sake of brevity, we're going to fast forward to the Slackware configuration. Now it wants to configure our system, so that's exactly what we're going to do. You should go ahead and make a boot disk. But for the purpose of this demonstration, I'm going to go ahead and continue with the configuration instead of making the boot disk. But once again, I caution you, make a boot disk. We do not have a modem onto this on this machine here. And so it says, would you like to set up your modem? The answer is no. This will ask if we want to configure a link to our mouse device. So we want to say yes if we'd like to set up our mouse. And we happen to have a Microsoft compatible mouse, so I'll just press OK here. It wants to know what our mouse serial port is. Ours is on COM1 under DOS or TTY S0 under Linux. Now it wants to set up Lilo, the Linux loader. In our case, we would want to do something like this, HDB equals CD-ROM, because we have an IDE CD-ROM drive. Now, Lilo can be put in a number of places, so we want to put it on the master boot record. We'll just go ahead and select the defaults here. It's putting it on the master boot record of our hard disk drive. We can choose a delay in here. And the reason why we want to have a delay is that I can select the order that I want to boot in what operating system. For example, at my system at home, I have Linux on there and I have DOS on there on my system. And so I have it set up where after 5 seconds, if no selection is made, it automatically goes ahead and boots into DOS. This is a concern for people that have a computer that a number of people have access to. So we'll go ahead and put up a 5-second delay. The first thing that I want to do is add a DOS partition to the Lilo configure file. Whatever partition I add first, that will be the default partition into which, after the time delay, Lilo will boot into. And so in this case, I'll select DOS, and if after 5 seconds I do not make any selection, Lilo will boot into DOS for me. It wants us to identify which DOS partition to go ahead and boot from. and I'll enter HDA1, which is our only DOS partition. But this can show you that there can be multiple operating systems on here, and at boot time you can select which one that you want to boot from, and ask for a short unique name for this. I'm going to say DOS. Now I want to add the Linux partition to the configuration file. The Linux partition that I want to boot to is the root partition, which, if you recall, is /dev/HDA2, or the second partition on hard drive A, and wants us to use a short name so that we can tell the bootloader which operating system to load into, and I'll select Linux. Next, I'm going to install Linux. Basic idea behind Linux is, Lilo, is this. At boot time, there is no operating system on your computer. And because there is no operating system on your computer, it does not know about the file systems. And because it does not know about the file system, it cannot read the lilo.config file that we're creating here. So what the Lilo utility does is it reads the information contained into the Lilo config file, and it puts that information onto the master boot record. The master boot record will contain information as to where the exact point is on the disk on our hard drive that we want to go ahead and boot from. And that's why when we install Lilo, and we put that information on the master boot record, if we make any changes to the Lilo config file, what we need to do is rerun Lilo again so that information will be rewritten to the master boot record. So we'll install Lilo now. Now it wants us to set up our time zone. We are US Pacific. And now that our system configuration is complete, we want to reboot our machine. So that's exactly what we're going to do. We're going to exit, and we're going to reboot our machine. We can do that by typing reboot. We're rebooting the system now, and we'll get up to the Lilo prompt, and within 5 seconds we have to react. And we can do that by hitting the control key, which will give us the boot, and I'll be able to type Linux in this point in time, and as we can see, it'll go into Linux. We have successfully installed Lilo and the Linux operating system onto our hard drive. The next step is, after that we have Linux up and running, we need to install X, and that will be our next step. When we want to install X, we have certain responsibilities of knowing what information is on our machine. For example, we need to know what video chipset that we have. We need to know what kind of mouse we have. We need to know what type of monitor we have. And if we know that information, and you can get that from the documentation, the user manuals that come with when you buy the hardware, then you should be able to install X Windows without a problem. Now, it's asking me to do a login. I type root here because I'm going to be logging in as a root user. And it notifies me that I have some mail. Now I need to find out some certain information. For example, I want to know what video chipset that I have here. I can use the utility superprobe, and superprobe will come back with information telling me what type of chipset that I have on this card here. It says that I have a Super VGA, and that the chipset that I have is a Cirrus CL-GD5434, and that it has 1024 kbytes or kilobytes of memory here. In other words, it has 1 meg of video memory, and it has a RAM DAC on board. So what I'm going to use, I'm going to use this information that I've got here using SuperProbe. Once again, that was SuperProbe with a capital S and a capital P. It's one word. I'll use this information when I go ahead and set up X. There's another utility if you notice here, I've did a ls or a list of all the files that are in /usr/bin/x11, and I can see that there is a utility called xf86config. This is the utility that I use in Slackware to set up X windows. This time, that's what I'm going to do. I'll type xf86config. It's going to ask me a number of questions. Okay, it wants to know what type of mouse that I have. I have a Microsoft mouse. It wants to know if I want to do cord middle. No, I do not. Wants to know if I want to emulate 3 buttons. No, I do not. Wants to know what type of mouse I have or where it's installed connected to. I can just go ahead and press the default here, /dev/mouse. I don't have to enter anything. It's to know if my keyboard, if I want it to generate non-ASCII characters in X. I don't want to do this. I don't want to change the key bindings. Now, it wants to know for the specifications on the monitor. I have looked to see what my horizontal sync in kHz in my monitor's manual is. Found the information there. Now it wants to know what the range of my monitor is for the vertical sync. I found that is 1. And now I have to identify, enter a string, which means just type in a name. I don't have to do that here. I can go ahead and just press enter and it'll create a default name for me. That's what I'll do here. And now it wants to know if I want to look at the card database. Say yes. And I can go ahead and see that I don't have any of these video cards here, so I'll press a space. Or I'll press enter to go to the next page. I happen to have a Diamond Speedstar 64. Notice that it has the CLGD 5434 that I found out was a chipset using SuperProbe, but I also know that I have a Diamond Speedstar 64 card inside of my computer here. So I'll be able to answer this one with the number 31. And it's telling me here that the server that I need to install it onto is the XF86 SVGA server. Well, that's the one that I installed during the installation of Slackware. And now it wants to determine which server to run. Well, I'm going to use the SVGA server that I selected during the installation, which is option 3. But I could also choose number 5, which is the server from the card definition, which once again is the SVGA. And it wants to know if it wants to set up the symbolic loops that are needed to run X Windows, and yes, I want it to go ahead and do it. And it asks me if I want to set it into its predefined location. Yes, I do. Now it wants to know how much video memory that I have on the card. If you recall, using SuperProbe, I found that it had 1024K, which is option number 3. Now it wants to know information about the card definition for the Diamond Speedstar 64, but I'm going to just go ahead and press the enter key here, and default information is going to be entered for me here. I don't need to have a clock chip setting here because it warned me not to put one during the super probe, and it doesn't want to have it probe clocks, and the card definition says not to probe clocks, so I don't want it to be done. So I say no here. Now here are what the resolutions that the server will set up, and this is what it has for by default, and I'm just going to say that the modes are okay. And now it's going to write the XF86 config file. This is the file that when you boot X, it looks at that file to be able to determine how to display onto your screen. I have XF86 config, the configuration file written, and I should be able to go ahead and start up X. And I can do that by typing start X. And if I did everything correctly, X Windows should come up and run. Now we have X Windows. It's installed under Slackware. And you have the opportunity now to explore, use your mouse to navigate around in X Windows, to bring up various applications, and to install the applications that we did not install during this time.
What resources are available to the Linux community?
There are many resources available to the Linux community. We have the news groups such as comp.os.linux and all the subtopics that are under that. There are a number of periodicals that commonly carry Linux articles, Byte Magazine, and many others. But the primary periodical is the Linux Journal. There are many books that are out about Linux now. There's Yggdrasil's Linux Bible, which is a collection of all the how-tos and all the documentation produced by the Linux Documentation Project. There are many good books like Running Linux by O'Reilly and Associates. And then, of course, there are many, many worldwide websites that have many, many good resources for it. One of the primary ones is at sunsite.unc.edu or tsx11.mit.edu. These are the primary sites that you're going to find information at on Linux.
I have DOS on my hard drive. Can Linux share my disk?
Linux can share your disk with many operating systems. This is done in a variety of methods. One of the primary methods is called Lilo, or the Linux loader. When you have the Linux loader on your machine, you're able to, at boot time, select which operating system that you want to. This is just one of the many mechanisms that are available. Other mechanisms are loadlin and bootlin.
Why would I ever have to recompile my kernel?
One of the primary reasons that you'd want to recompile your kernel would to be add or remove features from your kernel. This can significantly reduce the size in memory that your kernel is going to take up.
How do I remove Lilo?
The easiest way to remove Lilo is to take a MS-DOS boot disk 5.0 or greater, and take the DOS disk and insert it into your computer and boot from your DOS disk. Now your DOS disk has to have fdisk on it, and then all you have to do is simply enter fdisk/MBR. That stands for Master Boot Record. So you enter fdisk followed by a space, a / and MBR.
How can I find out what kernel I have on my Linux machine?
Finally, a simple question. Okay, it's very easy to do. All you need to do is enter the command uname-a.
How can I find out how much memory is available?
You can find answers to questions like this or any of the answers to system resources that are available by examining the files underneath the /proc, that's /proc directory. Go into that. You can look at it with an editor, or you can use the cat command on the files that are there, and you'll find a lot of interesting information under your proc directory.
What development tools are available?
There are many development tools that are available for Linux. The complete GNU tools are available. This includes compilers, symbolic debuggers, RCS, and a wide variety of other tools that are available. Languages, everything from Smalltalk to Ada, Modulitude to Fortran, as well as the common and popular C and C++ tools are all available now, along with many types of windowing GUI systems that are out there. There's Tickle, TK, Fresco, and there's Perl. Of course, Perl is available. So just about anything that you can think of is available on the system for doing serious development work.
Can I run my existing DOS and Windows software?
You'll be happy to know that a lot of your software is capable of being run under emulators in Linux. Right now, there is a very good emulator called DOS-EMU. That's DOS-EMU, which stands for DOS emulator. The DOS emulator can run the majority of DOS software on your system. This includes things that need to have DPMS memory protection. Also, there is another emulator called Wine. That's Wine, as W-I-N-E. That stands for the Windows emulator. It's not in that mature of a state right now, but I have run Solitaire under it. That's what I chose to run, and it worked fine under the Windows emulator. I've heard stories that people have run other software, but I don't have personal experience with it. The best place is to check under the news groups as to the current state of what Wine is at.
How much hard drive space will I need?
That's always a gotcha question. While you could get off probably by using 10 megs on a small hard drive on a 386SX, you probably won't be able to do very much. What I recommend as a minimal partition to doing useful work is somewhere in the range of 200 megs. I recommend at least 8 megs of memory for X Windows.